We're gonna, yes, sir. Okay, we're gonna take a look at finding the length, distance formula. Now, often when we go and grab a ruler and we measure, we always start at the end and count through, right? What happens if the only thing that you've got to measure is a broken yardstick, a broken ruler? It doesn't start at zero, but I've got numbers on it that I could go and use to measure with, right? I could start at one place and go to another, and I could figure out what it is. Kind of the same idea here. So if I ask you, how far is it from here to here? Well, it'd have to be 3 because that's at what? 1. That's at 4. So I could count. But what happens if I was looking at the 4 and I was going to 3? Or correction, going down 3 to 1. I count backwards. Okay, so if I've got, so you're saying 4 minus 3 gives me, or if I want to know how far it is, 4 minus 1 gives me, what happens if I take 1 minus 4? That's right, you can't have negative distance. So that's where this absolute value sign comes in. So, next thing that I want you to make sure that you put into your little books right at this time. I want you to put this in right now. Put this in right now. Yes, sir. Well, it's too late. We got to get going, so you'll have to write out your. Oh, Isaac, don't worry about it right now. Just put it into your notes so that you at least have it to use for today. Now, one of the reasons why I want this information in front of me goes back to this whole idea that everybody thinks that mathematics is way too difficult. This tells us exactly what we need to do. Okay? Given a coordinate, first coordinate x1 and y1, second coordinate x2 and y2, where do these things go? It's kind of like when you're supposed to put away your clothes after they've been washed. You've got a drawer for socks, a drawer for shirts, a drawer for pants, a drawer for this, and a drawer for that. You put each thing in the drawer, correct? Same idea. It tells you exactly where to go. So, let's give this a try here. How far is it apart? Now let's see. I'm right here, so what number is that? Negative 3, and this one is here obviously at 4, right? If I was at 0, we counted like we did before. That'd be 1, 2, 3, 4. This would be 1, 2, 3. Okay? So 3 and 4 gives us a grand total of 7. Now, what happens if I want to use that distance formula with the absolute values? So distance is going to be equal to the absolute value of, what was one of the numbers? -3 minus 4, the other number, which gives us the absolute value of -7, yes? What's the absolute value of 7? 7. Now, you're not always going to be able to create a number line, put the values on it, and sit there and count. I mean, if you've got extremely large numbers, that's a pain. Or if you're dealing with things that have decimals and fractions, again, that's a pain to try and draw that all out. So make sure that you understand what we can do. Let's try this one. Okay. Now I want to use the distance formula. Well, if you remember back to when we were playing with right triangles here the other day, could I draw this in here and make this a right triangle? Okay. How far is it from here to here? 3. How far up is it? 4. Anybody remember what I said whenever you got the legs that are 3 and 4? 5. So this has to be 5, right? Now I could use the Pythagorean theorem to do that. You know, the 3 squared plus 4 squared is equal to c squared. 9 plus 16 is equal to c squared. So I end up with 25 is equal to c squared. So I end up with 5 being equal to c. We've done this before. We know how that goes. So how does this work with the distance formula? Now let's plug it in and see. Now the first thing we got to do is get our x1, y1. There. And x2, comma, y2. So what should I put down for my first point? Well, I could put down the 1, comma 2. For the second point, I could put down what? 4, comma 6. Now, distance formula is equal to the square root of x2 minus x1 squared, yes? Plus y2 minus y1 squared. Is that right? Okay. So, now I plug it in. D is equal to square root. What number is x2? 4. So I got 4 minus 1 squared plus y2 is 6 minus 2 squared. So I just pulled it right out of the information. It just set it down, right? Have I done anything super difficult yet? No. Now I realize this is going to be one of the difficult parts of this. Can you subtract? What is 4 minus 1? 3 squared. Plus, what is 6 minus 2? 4 squared. The most difficult part about mathematics is actually taking the time and effort to write it out. Everybody says, oh, I can do this in my head. I don't even want to do it in my head. I can't. What's 3 squared? 9. What's 4 squared? Square root of 25, which is 5. Well, one of the things you'll understand here is the distance formula is actually based upon the Pythagorean theorem. We can go through and make any 2 points into a right triangle. It doesn't matter whether the decimals or fractions or whatever. So, let's try this. Do I have to go through all of that again? Because if I take a look at the coordinate here, this coordinate is -6, comma 0. That coordinate over there is 1. It's not 0, I was looking at the wrong thing. My bad. -6, comma 3. Is that better? Yeah, figured. And I seen that O down there, and it just, 1 comma 3. My brain overruns things every once in a while. Do I have to really worry about this 3-bit? No, it's just a straight line, right? After all, if it's just a straight line, I can get by with that, right? Was that a straight line? Yeah, it was. It was a diagonal line. What kind of a line is this one? Horizontal. So if I got a horizontal or a vertical line, do I have to worry about the other point? No, the other coordinate, I should say. So that means I just got the absolute value of -6 minus 1, which gives me the absolute value of -7. So the distance is 7. Is this true? Well, how far was it this way? 6. How far was it that way? 1. How much total? 7. There are a lot of different ways of looking at this. Sometimes it's easier to look at it one way than it is the other. So that's why I kind of show you guys multiple ways of thinking about this. So what I'm going to do here is I'm going to give you about 30 seconds, and I want you to answer this question. Alrighty, so let's see. Kara. Wow. Okay, what number is this? -7. What number is this? 5. So distance is equal to the absolute value of -7 minus 5. So I get this equal to the absolute value of -12, which gives me 12. Scared me you answered, but I should have known you'd answered that first, right? So, okay, I'll give you about 90 seconds. I know, way too much time. There you go, 90 seconds. Give this a try. That help? Ready? 6. Storm. Either finished? You got 4. Seems reasonable. Okay, well, let's check this out. First thing I want to do is I want to identify what the coordinate is. So this coordinate here is -5, -3. Okay, so that's S. And t, it looks like, is going to be negative 2, comma negative 6. Everyone in agreement with me? Okay? So, distance is equal to square root of, that's going to be negative 6, or actually negative 2, sorry, minus negative 5 squared plus negative 6 minus negative 3 squared. Usually if somebody's going to make a mistake, it's going to be here with these signs. Why? Oh, it's minus in there already, so I don't have to put it in. That's generally what happens with this. So square root, go across, that goes plus plus, so that gives me 3 squared plus plus negative 3 squared. So square root of 9 plus 9, which gets me to the square root of 18. Now it asked us to go through and round to the nearest hundredth. So grab the calculator, turn that on, turn it off, and we will take the square root of 18, and I end up with 4.24. And how many places? Nearest hundredth. So we end up with it being equal to 4.24. Okay. So you're on the right track there, but shortcut, huh? What's a shortcut? Tell you what, you can come work for me then. I pay you well, I just kind of straighten it out and guess a little bit, count it out. Not a good. I could do that for your grade too. Would you like that? Kind of look at it and count. So, is it a good idea to try that? Absolutely not. Ballparkish, maybe. It might be a good way to use to estimate, okay, if did I get a value close to that? Yeah. So I'm probably in the right ballpark. But that's not how we do it. Nice try, though. So, here we go. That up there, and I'm going to give you another, oh yeah, I'll give you about 90 seconds to take care of this one. 13. 7? Okay. Now, she says 7. Make sure I help write it out decently. Well, if I plot the points, 2 comma 3, 1, 2, 1, 2, 3, then 2, negative 4, 1, 2, 3, 4. Okay? They're on a straight line, right? Now, one of the things that you have to do in mathematics is look at what you've got. Are there commonalities? Well, when I look at this, I see that there's a 2 there, and I see that there's a 2 there. Oh, they're on the same x line. So that means I only have to worry about the distance between those. So that's the absolute value of negative 4 minus 3, absolute value of negative 7, absolute is going to be 7, so our distance is equal to 7. Sometimes it is just that simple. So, give me a couple of minutes and play with this one. Tristan, what you got? Oh, shoot. Well, okay. What do you got, sir? 173.3. Yes, ma'am. What? 17.3. Okay. Well, give this a try. Occasionally, we get situations like this. We got numbers. What do we do with them? Now, there isn't anything that I can do by looking at those answers and saying, okay, I know what you did there, I know what you did there, and I know what you did there. I don't know. The only way for me to tell is if I see this. Distance is equal to square root. Okay. Now, 120 and 0. 0 and 125. So are they on a straight line? No, they're not on a horizontal line. They're not on a vertical line. So that means I'm going to have to use 125. Whoops, 125, sorry. Minus 0 squared plus 0 minus 120 squared. Will that work? Okay. So that means I got the square root of 125 squared plus negative 120 squared. So far, so good? So we end up with, oh man, those numbers are way too big. I'm going to have to use my calculator. Turn that on, clear that out. Let's see, 125 squared gives me 1,15625 plus. Now I need 120 squared, and I end up with 14400. Okay. Now I'm going to end up having to add 15625. Boy, I got some big numbers here, don't I? Square root of 30025. So now I got to take the square root of that, right? Here we go. So we've got second, get my square root, and 30025. Okay? And I end up with 173 point, and it says nearest tenth, right? So 3. It's not right, huh? If each unit on the coordinate plane represents 10 meters, so I still got to go and times that by 10 yet then. So that means that would end up being 1733.3 meters. Oh yeah, that should have been, yep, 1732. Yeah, you should probably, yeah, not round until the very end. So if I did that, 173, yep, 173.2, yep, come on, 28. Yep. So you got to be careful about what you're doing and actually read the instructions. That is generally where people are going to fall down, is because they didn't read the instructions. And pay attention to what you're doing. After all, this stuff is about as easy as it gets, simply because